In lab number 4, you will determine the rate of the reaction involving potassium persulfate reacting with sodium iodide. So the equation that you will be performing is this: S2O8 minus 2, that's the persulfate ion, reacts with the iodide ion, that's I minus, and that will give you SO4 minus 2, the sulfate ion, plus I2. This is all done in aqueous solution. And furthermore, to balance this equation, we'll add a 2 here and a 2 here. So the rate of this reaction, or how fast this reaction proceeds, depends upon two things. It depends upon the concentration of your persulfate ion. If you have more persulfate ion, you'll get more sulfate. It also depends on the concentration of the iodide ion. If you have more iodide, you would get more product, iodine, diatomic iodine. So concentration is one determinant on how fast this reaction proceeds. The second determinant is how fast these reactants decay. They could decay with first order, second order, or zero order kinetics with respect to persulfate ion, and they can decay with zero order, first order, second order kinetics with respect to the I minus iodide ion. So we summarize all of this with the rate law. Rate is equal to the rate constant K, this proportionality constant, times the concentration of S2O8 minus 2, the persulfate ion, raised to the power of its order, the order of the reaction. So this could be to the power of A, and times the concentration of I minus, raised to the power of its order, B. So you may already know that this order, this exponent, is the order of the reaction, and with respect to persulfate, it could be zero order, first order, or second order. And with respect to iodine, it could be zero order, first order, or second order. So the kinetics of reactant decay are important, as well as how much you start off with initially. So if it's a zero order decay with respect to persulfate, then you have a different set of equations. If it's first order with respect to persulfate, you'll have a different set of equations for half-life and decay of the reactant at a certain time. So the equations are going to be different. The overall order of the reaction is A plus B. So this is the reaction you'll be performing in lab number 4. Couple of comments. You have potassium persulfate. The potassium is just a counter ion. And you'll have sodium ion, sodium iodide. The sodium ion is just a counter ion. So if you see any counter ions such as K plus or Na plus, they really don't play a role in this reaction. You'll also see Cl minus. That is another counter ion that really doesn't play a role. These counter ions just make sure there's not too much negative charge and not too much positive charge when you do this reaction. So you'll be performing this reaction in the lab, but as a twist, you're going to determine how fast this reaction occurs by detecting iodine. Okay, so it's an indirect detection method in terms of assessing the rapidness or the kinetics of this reaction. So this is the main reaction, and we're going to indirectly detect iodine, and with that determine the rate of the reaction. So your job is to determine A, B, the orders of the reaction, and to determine the rate constant for that reaction. Be very cognizant of your units. Okay, this is concentration, this is concentration. Your rate is usually some concentration over time, so the K, when you solve for that, is going to have the appropriate units. So the units of the proportionality constant K are definitely going to vary. So important point number 1 is to realize this is the reaction you're working with. Persulfate ion reacting with iodide, giving you sulfate and iodine. There's a second reaction that we will couple this with, and that is this reaction shown here. We have iodine reacting with this molecule here, S2O3 minus 2. Okay, this is called the thiosulfate ion. This is called the persulfate ion. So reaction 2, or the coupling reaction, is the iodine reacting with the thiosulfate ion, and that product that is yielded is 2I minus, to balance out the iodine, plus S4O6 minus 2. This S4O6 minus 2 is called the tetrathionate ion. Okay, we're not interested in reaction 2. We really are interested in reaction 1. But what this is a coupling reaction. So when you perform your experiment, put a certain volume of a certain molarity of persulfate and react it with a certain volume and certain molarity of iodide, what happens is you'll generate I2. This I2 will react right here with the thiosulfate that you put in. Okay, I believe the sodium is the counter ion for this. This I2 that's made here is going to react with the thiosulfate. And that thiosulfate is going to produce I minus and this tetrathionate ion, which we will not worry about. Now, what happens when this thiosulfate ion gets all used up? When this thiosulfate ion gets all used up, what starts to build up? This I2 starts to build up. The minute this I2 starts to build up after all of this thiosulfate is depleted, this leftover or residual I2 will react with the starch to give you color. So the indirect detection of this reaction and in turn the indirect measurement of how fast this reaction proceeds is really indirectly measured by how fast this thiosulfate disappears, which how fast it disappears depends on the appearance or how fast product I2 appears. Once I2 appears and all of the thiosulfate gets used up, the I2 builds, reacts with the starch that you also put in the test tube, and that gives you your color. So you're measuring the appearance of color and how fast that appearance of a color occurs per unit time, minutes or seconds or however measurement you see the color. And that color tells you how fast this reaction proceeds and through which you can be able to derive the rate law. In this lab, you will determine the rate of a chemical reaction. The reaction is between sodium iodide and potassium persulfate. Now that reaction can occur fast, slow. It really depends what fast, slow means relative to some reference point. But one thing that you will do is determine the rate law and the rate of decay of this reactant, as well as the rate of decay of this reactant into its corresponding products. Another way of calling the rate of decay is the order of the reaction. The order of the reaction with respect to sodium iodide, one of the reactants, and the order of the reaction with respect to the second reactant, potassium persulfate, also known as K2S2O8. So let me just go over what you'll put in to the test tube to determine how fast these two will react. So if we can just zoom in here, this is our first reactant. It's our main reactant, and that is sodium iodide. This is sodium chloride. All right, that's just going to provide a counter ion so that there's no buildup of excess cations or anions. The third is sodium thiosulfate. The purpose of this is to react with the iodine, and once all of this is used up, the iodine will react with our fourth reactant, and that's the starch, and that's going to give you the blue color. Our fifth reactant is potassium sulfate. Again, just like sodium chloride, its job is to simply act as a counter ion so that there's no excess buildup of too much positive charge or too much negative charge. And our sixth is our real reactant, and that is potassium persulfate. So once again, it's worth illustrating that these two are our reactants that you will determine the rate law for, as well as the order of the reaction with respect to this reactant, as well as this reactant. Everything else just helps facilitate your measurement of the rate law. All right, it's very important that when you start your experiment that you add your reagents in the order that is specified. So first you want to add the sodium iodide. That's your reactant. Then you'll add your sodium chloride. Then you'll add your sodium thiosulfate. Remember, the sodium thiosulfate reacts with any iodine, and once all the thiosulfate is used up, the free iodine reacts with your starch. And then you'll add your potassium sulfate. That's our final reagent, and that's going to be your persulfate, your potassium persulfate. So this is where you want to get your partner involved and time it, because immediately once you add your persulfate, potassium persulfate, that's when you want to hit the timer or check your watch or hit start on some sort of clock. So let's begin with our first experiment. You're going to do 5 experiments. The first experiment is just going to be straight up adding 2 mils of everything except starch. In all of your 5 experiments, you'll just add 1 mil of starch. So let's start. We will begin with the sodium iodide. Make sure you get a big, nice, large test tube with an appropriate stopper that will fit in. So I'm going to add 2 mils of everything except of the starch. So I'll utilize a glass pipette, and first we will begin with the sodium iodide. Okay, that's the sodium iodide. Here is the sodium chloride. We add 2 mils of that. Two mils of thiosulfate. One mil of the starch. 2 mils of the potassium sulfate. Now finally we're going to add our 2 mils of potassium persulfate. So you want to get your timer ready. I have a 1 mil pipette, so I'm going to have to do this twice. There's 1. And the minute I start adding my 2nd mil, the reaction is going to start. So the reaction is going to start now. Okay. So I do some tapping. And I check my watch. Or if you have a partner, set your timer. Periodically start tapping every now and then. So I've made note of the time. That's your color reaction. So in your second experiment, you're going to double one of the reactants. I believe it's sodium iodide. And in your third experiment, you will double the second reactant, which is the persulfate. In your fourth experiment, you're going to raise the temperature and add your persulfate at 35 degrees. And in your fifth experiment, you'll repeat this exact same procedure that what I have done, but add some copper sulfate. The copper sulfate acts like a catalyst. Here's some potassium persulfate that was actually sitting in about a 37 or so degree water bath for 5 minutes or so. So let's see what happens when we put that into our sodium iodide mixture. I'm going to put 2 mils in. Check the timer. patient. All right, see something happening here. And my reaction is complete, so you want to measure the time that the yellow appeared. This is with the potassium persulfate sitting in a roughly 35 to 40 degree water bath. When I took it out of the water bath, the temperature read about 37 degrees or so. Before I add my potassium persulfate, I'm going to add 1 drop of this copper sulfate catalyst. 1 drop is all I need. Get it in. And now I will add my potassium persulfate. That's a pretty good catalyst if you ask me. All right, so that's going to be this experiment. The main point is to get the order of the reaction and get the rate constant. So you want to make sure that your times at which you see the color change, you want to get that as accurately as possible. Do duplicates of each reaction and determine whether the rate of decay of iodine, sodium iodide, or the iodide ion is 0 first or second order. Determine if the rate of decay of persulfate is 0 order, first order, or second order. And there's also a part where you'll have to use Arrhenius equation. Lets us understand the effect of temperature on the activation energy. So 5 experiments. The first 3 experiments, you're going to change the concentration of persulfate and iodide. In 1 experiment, you'll double it, leaving everything the same. And the 3rd experiment, you'll double the other reactant, leaving everything else the same. So really, you have 3 experiments for which to extrapolate the rate law and the orders of the reactions. The 4th and 5th experiments involve the use of temperature and the effect of temperature on that time in which you see the color change. And your 5th experiment tells you about the effect of a catalyst and how a catalyst affects the rate of the reaction. So practice safety, have a good time, have fun, make sure you get your timer ready. I think during the demo my timing was a little bit off. That's where you want to use your partner to get that time. So work together with your partner and have a good, successful, and fun lab. Thank you.